Hey guys, welcome back to the channel. I have another PCM test, this time in a marine ECM or PCM. This is 8.1 S. Well, it is a 496, but it's a Hrzn MIE. So this is sent to me by Michael Clates from Delaware. He said it has no spark, false on all 5-volt sensors. Alright, so the computer was halfway open when it got here, so hopefully it was him that he opened it up, because otherwise this definitely was going to create an issue on him. Alright, so let me just show you the connections. That is the computer in there connected to this big simulator right next to me on my left side. Alright, so I'm not sure if I want to, probably just this view is the best. Like that, we got more room. All right, I got the Diacom, which is the diagnostics for the marine computers. I got the oscilloscope connected, and I have, as you can see, the computer is on. That blue bar that we see right now is actually the COM bus. I always start with that test to make sure the computer is stalking, especially when I don't see a 5-volt reference, because I'm going to show you that in a second. I'm going to change the time to faster capture on the oscilloscope, so we can see how what that looks closely. Because when I go like to see the rest of the signals, maybe 10 milliseconds or 5 milliseconds per division will be enough, so I can see, you know, the tachometer is connected to the red. So let me, you guys can see that in there. Oh, I don't have the meter in there. Okay, perfect. So you can see the computer is on. We don't have 5 volts. So that is definitely immediately checking his concern. I'm going to, to turn this off to see the fuel pump, which is right where I'm pointing in here. You can see how now the communication went away. Right, I'm going to power it on. And we got the main power relay went for a second, and then the fuel pump. Oh, that's actually the horn or mill. I need to select the signal. I have now selected the signal for the cam and crank, so give me 1 second. I have created you know, a lot of signals that I use for my tests. All right, I'm gonna write that one in. Okay, that should be all good to go. And the computer might run only because it's connected here in a simulator. Definitely with 5-volt reference dead, it would not. Why? Because the sensors need the sensor ground and the 5-volt reference in order to produce a signal. In this case, I'm injecting the signals with my simulator, so we might be able to make it run. I have to put some RPM. This now takes forever to start reading. I'm right now in 20, 30, and I'm spinning like a whole turn. Okay, finally it's picking up 80. I think it's around there. Yep, it does run. All right, you can see the signal. Let me see what is. I'm going to change this to a farther capture so we can see a little more on the signal. Again, the red signal is the tachometer. Let me go over to the, I'm only in 300 RPMs. Gotta increase that to like at least 750, 650 to 700 is a normal RPM. Now you can see more of those red signals from the tachometer. So we got communication. I also have a substituted value for the AEC and it's on. Again, all this due to being here. Throttle position sensor a little on the low side. Let me raise that up. I like to keep it in 7 to 10%. The rest of the values I usually don't move. Everything else is looking good. At least the computer, even though it took that hit, because I mean it's burnt inside. I can smell it. And but at least the rest is good. So I'm going to move the tachometer signal to one of the injectors. Pick an injector one, just choice. Let me go over to the oscilloscope so we can, I'm going to put a trigger what the trigger will do, which is right now on channel A, which is, you know, that blue bar is not going to be able to stop that. But if I move it over to channel B, which is a more or a slower signal, it can do it. I'm going, since we already know that that tachometer signal is also good, sorry, not the tachometer, the CAN bus signal is good, I can move the order channel from there to one of the coils, because this has 8 injectors and 8 coils. And the coil signal will be, it's an EST, let me make sure, connected into the wrong one. Now I'm in the correct one. It's a 0 to 5 volts, around, 0 to 4 realistically. And I have on the bottom of that screen where the, where the signals are showing, I have a min and max on the blue channel and a min and max. Not sure why the other one is not showing. And a min and max for the red channel, so you can see the minimum and the maximum of the signal. So it's a nice and clean injector waveform. Is being pulled pretty much to ground, 65 millivolts. That's 0. That's perfect ground. So that driver is good. We can see oscillations left over at the end. Again, I'm in injector 1 for the ESC signal and sorry, for the coil, and on the red on the injector, as you can see here. So Michael, your computer is repairable. Definitely, I can definitely repair. When I see a computer that I can make a run with this, I can definitely be able to repair it. But it is a very extensive repair due to the damage. Let me stop this. Yeah, let me stop this and turn the computer off. I'm going to take all the stuff out that we don't need. You can see now that there's no voltage because it's off. And you saw the disconnected and all those little bars are showing in there. Those are that I use for pits. You can see the ECM is not responding because I turn it off. So I'm going to disconnect from the computer. Sorry, I tried again. So, okay, now I disconnected from the computer, so we should have no more of those in there. And the next thing that I want to show you is how that computer looks itself. Come on. All right, perfect. So I'm going to move to this camera, and I'm going to unplug it so I can flip it around. And we can see the damage in here, and this is not just there. Now it's the circuitry that is involved into those signals that is damaged. So I'm pointing right here and right here. This is completely burnt. All right, guys. So I'm waiting right now on Michael's approval. I already sent him the quote, and let me see. He said, okay, when will you need for your information? I opened it just to see if it got wet. Okay, so he said that he opened it just to see if he got wet or not. As you see, I got his ID here. These cameras are super good to pick up things. So yeah, Michael, okay, so I got the approval, so I'm going to proceed with the repairs, and I will be stopping the video and then showing now the fully repaired computer and working good. So I'll be right back, guys. All right, the repairs are done. I forgot also to show you the actual full history, and that's very important for him as well. So let me move you over here and get my circle on so we can read that completely. So the ESC 7 and 8 open in here is myself. So disregard that one. But I don't see, as far as history, and the only thing I can go by, I'm going to go fast to the bottom, because this is where we see the total engine running time in hours, which is 178 hours. So it has low hours, this computer. But we can see the map sensor input low for almost 50,000 seconds. So that's the only thing that I can really go by. Is no other fault. We got a Guardian strategy of 2 seconds, but this 5,000 seconds almost, that is on the map sensor. So I will think that is the problem. Either that, a shorter sensor, it will have to be shorted to power. check your harness, Michael. So again, I'm going to, now that I can show you this, this is the fault that I'm talking about right there. So if I scroll up, look at the hours, we have 78:45. Everything else is pointing on like pretty much the minute that they got before being here. Because we see here 178.45, we got now minus 56 degrees Fahrenheit. That is impossible to be reading, especially this time of the year, right? The manifold air temperature 32 degrees. So this is because the same thing, it burned the 5-volt reference, the circuit, and now it's not running or barely running because I'm not even sure how this was even running. But again, if we go over to the next fold going up, we have the same thing, 178.45. So I don't have anything else before that. Usually I get more hours of fold history, but that's not the case in here. TPS low. Again, we're now reading minus 50 and minus 50 on the manifold air temperature. So it's getting even worse, right? Because before we got at least 32. Now it's minus 50. So if we go over to the next fold, the same hour, so nothing in here for me to see much. We can see the engine is not running. It's just a stall. So as long as it's stall, even crank and die. The battery voltage is okay, 12.49 after a crank and a stall. That's actually not bad at all. Next fold, same hours. Now we're reading a little bit of voltage and coolant temperature. So these could potentially be right here, right when I connect it and run it. Because we can see now in the next fold as well with the same amount of hours, right? So because the clock didn't change, that we have 161. That's definitely my temperature, my coolant temperature 161, and the manifold air temperature. Look at those two, 93.20. So that's why when I connect my equipment, if we go here, look at the temperature right here. I'm going to select a glass so you can see that 93.20, and my coolant temperature is 163. So that could change a little bit. I don't know, maybe 1 degree or so, but you can see how those two are really here. All right, so what I usually do, and this is after I repair, I reset the fold, not here, right? So I go into here and I erase the fold history, not the RPM, just the fold history. Why? Because I want to make sure that it's clean. Now, if I read this, it might be, I don't know, because you can always, you will always get faults, especially since I don't have the entire boat connected. But if we read the fault, and the faults are there, it's not that I erase it and they will not be on. So these are like a few level circuit high, the PTOT, EST7 and EST8 open. Why? Because again, those are not connected. But we can see now that all those seconds on the master flow sensor are gone. And the same thing on the Guardian Strategy. So hopefully, Michael, please correct the situation on the boat. Because if you connect this computer and you have not corrected that, it will burn the computer again. And that is not covered under my warranty. Under nobody's warranty. So no water damage and no burn components are covered under any repair facility or module warranty. You go and buy a brand new module from Mercury and you plug it in and it's shorted and you smoke it, you burn it. You try to go there, they will tell you this is burned. So I'm sorry, but no, it's not covered. No matter what, realistically, the dealers will never refund the money from any module. They will maybe tell you, okay, we're going to send it over for inspection. If you say, I crank and it's giving me O2 sensor faults that were never there. This is my original. I can plug it in. No sensor, O2 sensor faults. And with that one, that might be the case. But with a brand new module, I've never seen that. So maybe with a used one from a junkyard, you get faults that were on that car that were not yours. But brand new, never. And also the same thing I do here. I repair the computer. When I repair the computer, that's what I show it running and what faults are present in here. And I can show you, and you can see in multiple order of my videos where I move the ESTs, because this simulator, I don't know why, it has 8 injectors, but it has only 6 coils. I don't know why. Whoever designed it was smoking something that night. But it's okay because I can use 6 and then disconnect the other 2 and put the other 2. But I would rather have with a full probe or the Mark 50 where I have 8 injectors and 8 coils, right? Okay, let's go over to the test. Right now, I should have everything ready to go the same way. Let's put the meter, and we can see the 5-volt reference. I'm going to turn the computer off just to see, so you guys can see the 5-volt, the fuel pump coming on. Doing the prime, that is perfect. All right, so let me run it again. I should be ready to go as far as RPM. And we're running. You can see the ESC signal and the injector, which they were firing before. That was not a problem, but we never had that 5-volt reference circuit. And that was, I mean, the whole thing was damaged. I have to replace drivers, pre-drivers, the analog to digital converter, because they all go there. Sensors, where the sensors go? Analog to digital converter. He is lucky this was not a thermistor, because usually the temperature sensors go directly to the microprocessor. The rest of the sensors, they usually go to the analog to digital converter, which is a separate IC on this computer, but everything is working good. So Michael, your computer is ready to go. This will have a 1-year warranty, covered by Mike Salazar Diagnostics. I will put my seals on it. Please make sure that nobody opens this computer. If the seals are broken, it's void of warranty. I want to make sure that I am the first one to open it up. I want to see it, and I'll always record a video. If you have a core module that failed, I will record a video, me opening the computer, breaking the seals to see what happens. So we both be able to see if it was an intrusion, if it's a burn, or if it's a component that failed. Because realistically, a labor will not fail in a year, right? That will be more a component internal that can fail, and that can happen with electronic components. But I always double, triple check my labor components. Is out of my hands. They can always fail, right? But that's what I give you warranty. All right, guys, thank you so much for visiting the channel. If you're here, please don't forget to subscribe. I can also show you just quickly my website in case you have any computers, marine or automotive, that you need to send. I left the meter in there. Well, that's fine. It's not in the way. This is my website. Oh, the pico is. That's my website, Mike Salazar Diagnostics. The same thing as in this YouTube channel. If you go over to the channel and you see the name, that's the name exactly the same thing, Mike Salazar Diagnostics, and then .com. In here, under that big Y letters with my name, you have a Y box that says click here to fill this form and send a module. That works for all the modules. Instrument clusters, computers. Yes, please make sure that you fill all that information, and you can send me the module. If you want to email me, the black box is to open your email browser with my email already there, and then the chat button to chat. If you want to use the chat button and I'm not there, please leave your email so I can contact you. Also, on the left upper part, you have my telephone and my email address in there as well. All right, guys, thank you so much. See you next time. Bye-bye.